What's going on, guys? In this video we are going to be approaching the second part of the x-ray challenge, where we're going to be writing the codes for that particular challenge. So let's get right to it. So I'm going to open up my VS Code here. I'm going to write my codes. So basically, if we look at our analysis yesterday, we're going to try and create a program that will perform the function for these steps, starting from the loop part down to step 2. So first, let's start for the loop. So for the loop part, what is basically doing is just to look through all the data and divide it into sub lists, removing 0 from the list. So in order to do that, we're just going to define a function. But before we go straight to that part, let's get our data from our input file. We're going to have for test case in our input file is going to be for that we're going to have test. This first part is going to be number of values. So let's just name it number of values. Is equal to input. So now it's time to get our values that we're going to use for this code, which is going to be called values. So I'm going to have integer for in our input. So basically this is the main this is the main code that is going to be required for everything, so I don't need to explain anything here. So now we're going to initialize our total number of operations, which I'm going to call total time, and initialize it to 0. So our total number of operation or total time is going to be equal to 0 here. So now it's time to create the function that is going to take care of dividing this into sublists. So to do that, what we're going to do is just define it. I don't have any special names to call it, so I'm just going to call it by the step. But instead of calling it that part is not included inside any step, so we're just going to call it step 1 though, since we didn't include it or we didn't assign it to any step. So we're going to call it step 1, and we're going to have step 1. We're going to divide it now. So to do that, we're just going to loop through the list and check we're going to loop through this list here and try to find if it contains 0, and if it contains 0, what we're going to do is divide the list from that place. So now to loop through the list, we're going to do this for basically we're going to accept a parameter which is going to be the list, and here for value in list, or I think that is right thing to do. For value in list, now for each value in the list, we're going to check first. Before we check if it's 0, we're going to have our index here. It's going to be initialized, which is going to be incremented. Sorry, not initialized. Instead, we're going to initialize it here. So after that, we're going to have if that value is equal to 0. If that value is equal to 0, what we're going to do is divide it into sublists. So we're going to have an empty list here. Let's initialize that list. Let's call it empty list, or new list rather, to be equal to an empty list, and we're going to have our stop value and our start value. You know what it is soon. So that will be initialized to 0, and our start value as well will be initialized to 0. Oh, just remove the stop from there. We're going to initialize our stop here. Have this. Now for if this condition is met, what we want to do is append into this new list the values we're going to get, and what we're going to have as our value is going to be, first to initialize our stop value to be equal to our index. What we're doing it like this is so that for each value we get the index of that value. Now we want our stop to be equal to index, so what we're going to have inside here will be that list. I'm going to split it up or slice it from the start to the stop. So far for what we have gotten, I think it's a good breakpoint to check if we are on track. But before we do that, let's just have this, our stop equal to our start equal to our stop, sorry. So let's print this and see what we get. First we'll call the function here, step 1, and pass in our values, which is this. And now let's run that. So what we're seeing here is, for the first one, we're not having anything here, and for this part it's giving us 240. So what we want to do is basically make sure that 0 isn't included. Now we see that 0 has been removed from the list, because 0 has been removed from the list. Now indexing starts from 0, so in order to our indexing or our value starts from 0 here. It is incremented by 1. This is initially 0 and then is incremented by 1. So instead of the counting to start from 0, it starts from 1. Going to be bad, or which is going to affect the way that it slices the list. So that's why we are subtracting by 1, because it will be one step ahead instead of checking for the first part. So I think the best thing to do is to increment this at the end of the loop. At the end of the loop we increment our index. I think this will create a better list, and then instead of subtracting we'll just have that like that. And let's run this again. Sorry, I think we're making a mistake somewhere. Yeah, and that works well. And so we see that for this part that doesn't have any zeros inside, it's giving us an empty list, which is not what we want. We also want to retrieve that list the way it is. And we're also seeing that the end of the list here is not considered, since it stops at wherever it sees 0, or wherever it's wherever it sees 0, right? What we're going to do for that is we're going to write another if statement as well. We're going to check if the value, or if the index is equal to the length of our list, what we want to do is just have our stats. Okay, what we want to do is to append to that new list, or to this list that we're appending to, which is new list actually. The list slicing from the start to the end, so we'll not actually put stop here, so it will move to the end if the index is equal to the last, or is equal to the length of the list. So let's run this again and see. I think I made, okay, this is meant to be a conditional statement. So we're meant to have our index here. Let's run that again. So now this is better. This gives us what we expect or what we want. Our print statement is not meant to start be here. We'll put our print statement here, so to give us what we expect. And now we see that this is what we expect. So what it's doing here is that it checks the first list, and when it checks the first list, it checks if it has any zero. If it doesn't have a zero, it puts it into a new list like that, and if it contains a zero, it splits from that part. Now we see that this part is in containing zero, and we don't want that, so here our start should be incremented by 1 as well, so that since the first part is included and we are actually having our stop to be the index of 0, we'll have to increment. So we'll have to increment our start when we are initializing to our stop, so that 0 won't be included. And when we run this, now we've gotten what we expect, so that's a good thing. Now it's time to go to our step 2. In our step 2, or what we call the step 0 here, we check if the list is equal, the length of the list is 1, and if it's 1, we increment the total number of operations by that value inside it, and if it's 2 here, we increment by the max of the list. So we're going to do that here as well. For the second step, we're going to have another function called step 2. Now for this function, it's going to accept a list as well, and when it accepts that list, it checks through the list if the length of the list it accepts is equal to 1, it will increment our total number of operations. But first, we have to find a way of accessing this total time inside this our function. So we're going to initialize total time here as well to be 0, and have it here as a global variable. Now what we're going to do is increment our, okay, this is not what we meant to have it, sorry, not in this function, in the next function. We're going to have global total time. So good, now we're going to increment our total time plus the max value, or sorry, plus that value instead. We're going to have, but there's something wrong. Before we actually have this here, we're meant to loop, because we're going to get a 2-dimensional array here, because from this our output, we're seeing we're having 2-dimensional arrays, and it's our output that we get from our step 1 is that will pass into our step 2. So basically what we're going to do is loop through the 2-dimensional array for list in list, because there is actually a list inside the list, so I think this is the best thing to do. So we're going to increment the total time by the value inside that list if the length is only equal to 1, right? So we're going to have that. So this will bring out the for this particular list, or for a certain list, which is maybe if this is the first list that it brings out, to check if the length is equal to 1. If the length is equal to 1, it will get that value, like this satisfies that condition, so it will just bring out this value from the list and increment the total time by this value. So that's it for that. And we're going to have an else here, and if the length of the list is greater than 2, is greater than, oh sorry, it's equal to 2, not greater than 2. If the length of the list is greater than, I keep making a mistake. If the length of the list is equal to 2, what we want to do is increment the total time by the maximum value in that list. So increment the total time by the max value in that list. So if like here, this list satisfies the condition, so if it will increment by 4, since that is the max of the list. And something we have to do is, after we have incremented that list, we are done with that list, we want to remove the list from the main list containing both of them. So we'll have the main list and just remove that list, and also for here as well, we'll have the main list, so remove that list. So now this would remove the list immediately. Immediately total time is incremented and that list is done with. Now a separate condition could be a case whereby the length of the list is greater than 2, which is step 3. So we want to actually have a function that is going to look at that case or that scenario and give the perfect result for that scenario. So now we're going to have our step 3 here, and I like to call this step the recurser because it will call back step 1 after it has done what it's meant to do. So here we'll just have list again passed through. Now when we have this, we're going to have our global time also, because we'll be needing it here as well. Now we're going to look through, then since actually what we're going to have is also a two-dimensional array as well, or a two-dimensional list. We're going to look through it for list and list, and what the length is greater than 3. Obviously, for it to enter into this step, the length is going to be greater than 3. So it's going to have a list it will append. It's going to have a list it will append the result into and pass it on to step 1, if that makes sense. Here, well, we want to have a new list called nList, which is going to be empty, and we also want to find the mean value, that is the mean value in our list. So we're going to find the mean value in our list. Now when we find the mean value in our list, what we want to do is increment the total time by the mean value. But before we increment that total time by the mean value, we want to subtract each value in that list by the mean value. So we're going to loop through, or for value in LI, let's use something understandable. We're now going to append to our nList here the mean now when we're done with this, we want to call step 1, but before we do that, after we are done with this, we want to increment our total time. Increment our total time by the mean value that we subtracted with. And when we increment that, we want to recall step one, that is recalls or recall any of them. Step one. So here we're going to have step one, passing in our new list in as an argument. So when this calls step one with our new list that has been filtered, it will call step one with it, and step one will rerun this and actually divide the list again, because what we'll get from here is going to be containing zeros, because when we subtract by, let's say 3, since 3 is the mean here, when we subtract by 3 will turn to 0, and this will turn to 1, and this will turn to 2. So we'll have to remove the 0 from that list again, and when we remove the 0, we'll call step 2 again, and if this value for or if the condition for step 2 is satisfied, we will increment our total time, and if that is the last list, that will be our answer. So return step 2 with our new list in, and what we want to do here as well is to return step 3. In a situation where none of these conditions are satisfied, we want to return step 3. And when we're returning step 3, we want to pass in our list. Since this list that was passed here didn't satisfy any of these conditions, we want to pass that list into our step 3 and go ahead with it. And let's run that and see what we get. Let's print out total time here. Run that. Okay, I think that there is local variable is referenced for assignment in line 68. Let's see where the error is coming from. Oh, I see why that error is there. We're meant to call this inside here, and max argument is an empty. I think best thing to do is to try and make sure that we don't get any empty lists in what is returned here or from our step 1. So the best way to do that will be new lists. We'll reassign this new list to a new list, and have value for val in new list if val is not equal to an empty list. So this will take care of any situation where we have whereby the list contains an empty list. So let's check. Yeah, so basically that took care of that, and this is what it prints out. And from there we see that there is a mistake somewhere, so let's check for the mistake. We are checking the length of the original list, the two-dimensional list, instead of the one-dimensional list. So what we'll just do is to check this. Now let's run this again and see if we are right. Now that's the correct input. So from this we see that this is giving us what we expect. If we check our explanation yesterday or our analysis yesterday, we see that for the first part we got 9, for this part we got 101, and for here we got 3. which is what this runs. And we can try find how long it takes for it to process a very large amount of data. I got some data here. I think I have some here. Let's process this data, which is basically just 10 small, just a small amount of data below. But okay, before we do that, our print statement is not yet right, so let's have that adjusted to have okay, I'm missing something. So we'll have our test case. No, have our test case plus one to give us the index, or and also have our total time here. And when we save that, this should be in the right format. Yeah, this is now in the right format. Now let's go ahead with this. Save that and see how long it takes. So this is pretty much long. We can see this happened in 0.771 seconds. So I'll just pull up some files of the data that I used to practice. So I've pulled up some files here. This is there are 10 files in this. Let's look for one that is bigger. So there are 50 files in this. Oh, sorry, there are 50 test cases here. And let's just have that pasted here and save. And let's see how long it will take. So this was done in 1.132 seconds here, and we've got pretty much the values. And let's run a larger file. Now this is where I told that will be a trick. So just have a Ctrl A and just copy that here, paste that here, and I'll save it. Now let's run that. Okay, it actually ran, but I think I'm missing a file. Yeah. Okay, sorry, this is not the file that there will be a trick in. This one ran correctly and no problems. But now the last data that was given was 1000 test cases with extra large numbers. So what we're going to do is we're going to try this out and see what happens. So we've just copied that. Let me save it. See, this is even taking long amount of time to even save. I don't know why. For some reason my laptop is taking time. And now let's run it and see what happens. So guys, we've come to the end of this tutorial. Hope you enjoyed. I'd like to inform you guys that I'll be starting a series on Python for beginners, and we'll move up to advanced level, so watch out for it. And for this series, it's not yet done. Our next video will be looking at competitive programming from other sites and how to analyze them, and also writing codes for them. So watch out for the series. Make sure to like, comment, and subscribe, and I'll see you in the very next video.